Hello YouTubers, hello again, something completely different. Some time ago last year that is, I bought two items on eBay. One I hope would be useful, and the other one, it just looks such a unusual thing. I thought I'd buy it to find out what it was. And this is what I thought we'd look at this time. This is a Taylor Model 110B capacity resistance bridge. Taylor Electronics, Slough, Bucks, England. I've taken the screws out of it so we can have a look inside. And this is what it looks like inside. Now this is the first time I've seen inside of this. It's the very first time. So we've got two valves. We've got lots of waxies on here. You've got another one down the bottom there. I haven't got a clue about how this thing works. It's all new to me. Oh, there's two valves there and one here. Wow. Let's have a closer look. It's got some pretty good quality looking resistors there by the looks of it. I haven't got any paperwork on this at all. I haven't even looked. I will be looking. Just sitting there watching the end of Octopussy, a James Bond film that was on. I do like watching Roger Moore. Shame he's passed away, but there you go. No more from him anymore now. So anyway, I thought we would have a look at this. Now that tube on the top there is a Y63. Just bear with me a minute because we're a bit cack-handed here. See what these valves are. They're tight. I'm going to leave them for the moment because I don't know what I'm going to do with this. It's very well made, very tidy inside. Strange looking thing, contraption. So we've got the usual waxy capacitors. Just coming off of there, bit of tape. Yeah, well made looking thing, isn't it? Yeah. Let's get our light on the subject, we can see better now. That's better. I'm looking to see if there's anything burnt out on it. I'm not bothering to look at the capacitors because we know where they're going, don't we? Yeah, that's interesting looking thing. Old-fashioned webbing. Yeah. So the thing to do now, I suppose, is to go online and have a look to see what information we can find on this. Let's turn it round, get a better angle. It's a hefty old big transformer. So you're looking at this the same time as I am for the very first time. I've never seen this before in bits. I've often wondered what was inside. So obviously the usual thing, check the resistors. I think these will probably be okay, but we'll check them anyway. And obviously the paper caps are going to have to go. That's electrolytic there. 50 microfarads I see on that. Right, I decided I'm going to have a go at powering this up. The pin is in 240. which looks to me like it's black and red joined together. So that's what we're going to do. We're going to connect the red and black together. Right, we're going to power this thing up. Now I'm not restoring this yet because it's going to cost money, probably. And remember, we've just bought that generator, signal generator. I'm just curious, and when you've seen this, you'll be curious. So let me just run through things, how we got this set up. We've got the back off, obviously, so we can see any valves lighting up. It hasn't been touched in the back of here. It all looks pretty original. There's no rubber wires. That's a relief. These two wires, the black and the red, is for 240 volts with a selector on the back. 240 volts, and then dropping down in voltages on these two wires, one or the other, to black, for the transformer windings to get the right voltage. There was test leads on these two. Remember, we don't know what anything is for. No idea. So I took them out because I didn't know if they're going to be live or not. This side says leakage, so I'm assuming that this means that this is for capacitors and this side is for resistors, and this is the scale for resistors and this is the scale for capacitors. That's my way of thinking. Got it turned right down. Just in case you're not familiar with what I said earlier, this is a Taylor model 110B capacity resistance bridge, and it's got a plaque on there that says EV62. Sorry, no, it's not a 2. Start again. EV61426. We have our light bulb set up in case there's any shorts somewhere for the voltage to go. This is our amp meter, AC, right amp meter this time. I've got it in the box to protect the connections at the back so we don't get shocked. Back of this has been checked, it's okay, it's been done with black tape. That's our voltage. Our variac is connected but not turned on. So we'll remove all the metal screwdrivers and metal things out of the way. We've got to do now is link up. Hang on, we've got a wire off here somewhere. Hang on. I've taped up the wire for now. So turn it to one side. We've got our light on the other side, so we can see what's going on. See if any valves are lighting up. So let's have a go and see what happens. Power's on. Right, let's have a look, see what you can see. Slowly turn it up and see what happens. Oh, it would help if we plugged it in, wouldn't it? Haven't plugged it in. We haven't plugged it in. We're not plugged it in. Right, it's plugged in now. Okay, we start bringing up the voltage slowly because you don't know what's going to happen here. Looking at a light bulb in our amps. Up to 100 volts. Let's see if there's any filaments lighting up. Up to about 150 volts. Not drawing very many amps. We're on coming out to 200 volts. Oh, nothing. Hang on a minute. 2 secs. Right, I found out what the wire was. The whole setup wasn't linked up to what we were testing. So we start again. Bring the voltage right down to nothing. Power on. This time it is connected up. I thought I had checked everything. Right, start slowly doing the voltage up. I think it turns on. Oh, main's off on there. So you put it onto cap so it fires up straight away. And just start bringing up the voltage. So we're up to 100 volts. Our amp meter's gone up slightly. No filaments lighting up. Bring it up to halfway between 100 and 150. We've got a filament lighting up. Just turn the light off at the back so you can see we've got filaments glowing. Turn it up a bit more. That's our amperage draw, which is very, very small. And we're up to just over 250, sorry, 150. It's now on 200. So far so good. No bangs or whistles or pops or smoke yet. Good. Our amperage is creeped up a little bit more. Let's put it up just over around the 200. All our filaments are lighting up, that's brilliant. I'll just go up a little bit more on the voltage. That's about where we want it. Right, okay. No pops or bangs or whistles, which is fantastic. But nothing. Now, I'll turn this right down to nothing. Let's get a capacitor out. We have a faint glow on the Magic Eye, very faint. Right, on this test we've got a resistor, a 4.7 ohm resistor, and we're seeing if we can get anything on that. So I've just turned it over. Oh, it would help we turn on the power. There we go, power's on. That's come up to that. That's how many amps we're drawing. Drawing a little bit of current. It's halfway between 0 and 0.2, so I presume that's 100 milliamps. It's got 279 volts by the looks of that, if I got that right. I don't quite know what's supposed to happen. The Magic Eye is very dim. But yeah, well, at least it lights up. I'm glad I didn't have my hands on those crocodile leads that was there originally. That could have been a bit naughty. But yeah, not a lot happening. So it would be a question of checking the windings. It will need a new Y63 because it's very dim. Don't know if this is going to be any use to me or not, don't know. But when I did a check on the forum, I saw on there an old post of somebody posting about one of these, saying about the capacitance side didn't work. And the funny thing is, the capacitance on this doesn't work either. So it could be we're talking about the same one that was sold on eBay. The resistance size worked, but this side didn't. And he was asking for a schematic on it. So, yeah. So I suppose the next thing to do would be to check the windings. See if there's any blown windings. And then let's look at these caps. The usual thing. But like I say, I am not starting this project. I just wanted to see if this was working and what wasn't working. As it's been turned on for a few minutes, I thought I'd have a feel around to see what's warm and what isn't. Now, I put my finger on this blue capacitor, which is electrolytic. It says 8UF 450 DC, Tom Thumb, never heard of them. And also while I'm at it, I noticed that this cap here, this 50 microfarad 12 volt it says, it looks like it's been, that's a solder job there, I think, a big blob of solder. I could be wrong. So yeah, certainly interesting, isn't it? So I'll just have a play around with this. If I've got these caps, brilliant. If I haven't, I'm not ordering any more parts other than what we need for the Murphy radio. So I thought this might be of interest to some of you. There's another angle there. Yes, it looks fairly simple. There's not a lot of parts, but there's a lot of wires. It's very nicely made, isn't it? Very nice. So we know that the 240 volt winding is good. Otherwise we wouldn't have had anything at all. That's something. We know we've got filaments working, so that's another good thing. Yeah, nice little jubbly. I'll post this, give you something else to look at. As I say, it's going to need a new Magic Eye. That's for definite. Might be able to test these valves, don't know. We'll just see how we get on. See you later. Thanks for watching.